Hello and welcome to Maths with El Profelo. In this video we're going to return to a particular proof that we did earlier involving Wilson's theorem, and we're going to look to improve the efficiency of the proof and the readability, we'll say, of the proof, the ability to follow the proof, based on some work that my colleague Lori Gillander has done. Okay, and that is as follows. Right, we know Wilson's theorem says that if p is a prime number, then p minus 1 factorial is equivalent to negative 1 mod p. Okay, well, we're going to prove that p is an odd prime number, or excuse me, we're going to prove that if p is an odd prime number, then 2 times p minus 3 factorial is equivalent to negative 1 mod p. Right? Now, previously, right, in practice 3, we found that 2 times 100 factorial was equivalent to negative 1 mod 103. Right? So that was a particular instance of this more general situation. Right? So that was in practice 3, we found that. So how are we going to do our proof now in this situation? Okay, well, here's what we can do. Right? We know that p is an odd prime number, so we're going to say let p be an odd prime number. Okay, so we're going to let p be an odd prime number. Now, it is important, and this is going to be very important, that we know that p minus 1 is equivalent to negative 1 mod p, that p minus 2 is equivalent to negative 2 mod p, right? We could say that p minus 3 is equivalent to negative 3 mod p, right, and so on and so forth. Okay. Now, we know by Wilson's theorem that p minus 1 factorial is equivalent to negative 1 mod p. We know that by Wilson's theorem. Okay, and we also know that p minus 1 factorial is equal to p minus 1 times p minus 2 times p minus 3 factorial. So that means that p minus 1 factorial is equivalent to p minus 1 times p minus 2 times p minus 3 factorial modulo p. Okay, well, because we're working with this modular arithmetic, right, we also have previously discussed that p minus 1 is equivalent to negative 1 mod p, and p minus 2 is equivalent to negative 2 mod p, we can say that p minus 1 factorial is equivalent to negative 1 times negative 2 times p minus 3 factorial mod p, right? Which, on multiplication, we know that this is equivalent to 2 times p minus 3 factorial mod p, right? So therefore, 2 times p minus 3 factorial mod p is equivalent to negative 1, which is what we were trying to show. Right? So a very efficient approach to this proof based on this recognition that, that p minus 1 is negative 1 mod p and p minus 2 is negative 2 mod p. Right? So then if we use Wilson's theorem, right, and we simply rewrite our factorial, and then we use our substitution based on those residuals, right, the negative 1 and the negative 2. Well, negative 1 times negative 2 is 2, and 2 times p minus 3 factorial mod p is equivalent to p minus 1 factorial. And we know that p minus 1 factorial is equivalent to negative 1 mod p. So that means that 2 times p minus 3 factorial mod p is equivalent to negative 1, which is what we were trying to show, right? That it is in fact true, right, that if this is equivalent to negative 1 mod p, then negative 1 is equivalent to 2 times p minus 3 factorial mod p, okay? So once again, thank you very much to Miss Lori Gillander for the organizational strategy that she uses to clarify the simplicity, or the efficiency rather, of this particular proof. This has been Maths with El Profelo. As always, please reach out if you need help.